Welcome back to part 4 on quadratic functions. We are looking at part B here, and we have g of x equals 6x squared plus 12x minus 5. We need to put this in standard form or vertex form, and so I'm going to group the first two terms. Then I'm going to factor out the common factor so that factor out the leading coefficient so that my leading coefficient with the x squared is 1. And now I need to figure out what my third term will be inside the parentheses so that I have a perfect square trinomial inside the parentheses. And remember, whatever I do inside of the parentheses, I also have to do the opposite outside so I keep my expression balanced. I'll take 1/2 of b and square it. And this is my scratch paper off to the side. That will be 1 squared, so I get 1. When I add 1 on the inside, that's equivalent to 6 because of the 6 out front being multiplied to everything in parentheses. So if I added 6, I also have to subtract 6 on the outside. Now I have 6 times the perfect square trinomial, which I can then factor to x plus 1 times x plus 1. Remember that the plus 1 is always going to be the number inside the parentheses of the 1/2 b before you square it. And -5 minus 6 is -11. So now I have 6 times the quantity x plus 1 squared minus 11. So this is still my g of x, but it is now in standard form, which allows me to graph it a little more quickly. I know that my vertex is going to be at -1, -11. So it's going to be slightly off the graph paper, and I know that this is scaled by 6, so if I go over 1, I have to count up 1, 2, 3, 4, 5, 6. And it is symmetric about -1. So there will also be a coordinate point to the left of -1. And if I connect the dots, my parabola will look something like this. It's opening upwards. It has a vertical stretch of 6, a horizontal shift of 1 to the left, and a vertical shift down by 11. You could find the x-intercepts by setting y equal to 0, or g of x equal to 0. That would give you 1 equals 6x squared plus 12x minus 5. You could plug that into the quadratic formula. That would give you your x-intercepts. You could also find the y-intercept by setting x equal to 0. So g of 0 is equal to -5. And we saw that simply by graphing it. Our domain for this function is all real numbers. And the range for this function is from -11 to infinity. We need to find a function whose graph is a parabola with vertex 3, 4 that passes through the point 1, -8. Well, we know that a function, we'll call it f of x, has the form a x minus h squared plus k. In our case, we don't know what A is, but we know that the vertex is at 3, 4, which means we can fill in H and K. This 3 is H and the 4 is K. So we have x minus 3 squared plus 4. Now that we have substituted for H and K, we need to find A. We can do that by substituting f of x with -8 equals A times 1 minus 3 squared plus 4. And if you're not sure where I got these numbers, the 1 is through the point 1, -8. So that's where I got the 1 to substitute in. And the -8 I got from the y-coordinate or the f of x coordinate, and I substituted that in. Now I can solve for A. I'll go ahead and subtract 4 from both sides. That gives me -12 on the left and A times 4 on the right. Dividing both sides by 4, A is equal to -3. So if I want to write the function that makes all these statements correct, I can just say f of x equals -3 times the quantity x minus 3 quantity squared plus 4.